Hey y'all, and welcome back to Severely Overlooked. Today, I want to tell you the story of May 15th, 2022. I came across this radar scan saved off of my old iPhone a few days ago. Since I got my iPad, I've had access to a lot of saved radar data again that I haven't been able to see for probably about a year now since I got a new phone. Even well before I had the idea of making this channel, I found that storm so interesting. So, what happened? Before I get started, there's surprisingly little professional research about this event. A few news articles were written the day of, and that's pretty much it. So a lot of what I will be discussing will be what I could deduce from radar data, and I'm not a professional, so take it with a grain of salt. But with that being said, let's get started. On the morning of May 15th, 2022, Florida was under a general thunderstorm risk with no severe thunderstorms expected. Using this archive from Weather Underground, it was pretty warm for the middle of May, with the high temperatures peaking at 88 degrees. However, as you can see by those other graphs, the heat was not going to be the main weather story for today. Using the original radar scan here, you can see that the setup for the day was a lot like what I have shown on this channel many times over. Scattered rain showers develop into thunderstorms, occasionally putting out lightning strikes. And at around 1:30 p.m. local time, a cluster of thunderstorms consolidated into a larger structure of storms. At 1:44 p.m., a National Weather Service meteorologist reported seeing a tornado on the ground along Interstate 295 and Interstate 95 in northern Jacksonville. It was a small, drill bit-shaped funnel. On this reflectivity radar, it's hard to tell anything tornadic is occurring. It also doesn't help that the storm went directly over the radar site and was generally hugging the site for most of the time the tornado would have been active. By 2:11 p.m., the tornadic cell is seen beginning to merge into a small squall line with multiple other cells. This scan from over a year ago was a good start for this story, but I wanted to dig a little deeper.
You got the Beltway 95, and that's where those tornado warnings encompasses. Like I said, to 2:45 p.m. Let's pull up some of the information. I'm going to read off the warning here for you. The latest one, which was just reissued by the National Weather Service. Warning for eastern Duval County, northeastern Duval County, of course, here in northeastern Florida, until 2:45 p.m. At 2:16 p.m., so this was about 15 minutes ago, severe thunderstorm indicated, capable of producing a tornado just east of Jacksonville International Airport. It is moving towards the northeast at about 5 miles per hour, so very slow moving setup here. Key thing is that there is that potential for some damage. Now I do want to go back to the velocity. This is important because what this does show you is the couplet, and you can see that right in about there. That's movement towards and away from the radar. So basically going over, right over Route 17.
On screen now is an archival radar scan from Radarscope. This is also a velocity radar scan instead of a reflectivity radar scan. Just for a brief refresher, green on the radar indicates wind moving towards the radar, red on the radar indicates wind moving away. From what I can deduct, there was never a well-defined couplet or a radar indication where intense winds meet closely and begin to rotate. The first sign of potential rotation began at around 1:35 p.m. local time, where light winds began moving opposite of each other. By the next scan, the winds had intensified on both sides, giving readings between 20 to 35 miles per hour per each section of the swath. The benefit to the storm being so close to radar really shines through here with these velocity scans, as this is incredibly close to the ground. These wind speeds were most likely accurate. The negative also shines through when we look at the reflectivity radar. You might be able to deduce a potential hook echo at the time the tornado was spotted, but it's hard to say. Interestingly, the radar scan prior to the sighting minutes earlier indicated a heavy lump on radar. Now, this could be hail or very heavy rain, but the fact that this disappeared within the next two scans make me think possibly otherwise. This was at a radar height of only 400 feet above the ground as well. The official tornado report from the SPC says that the tornado hit a train yard. Could have just been some debris being lofted up into the air briefly? Who knows? Honestly, if it weren't for the National Weather Service employees' sighting to provide context here, I would say this looks like a downburst on radar. You could see two differing bands of wind together at the beginning of the scan, but they look to surge away from each other after a certain point. This is known as a downburst and happens when thunderstorms drop a massive pool of cold air from within, along with a large amount of rain and hail. Wind gusts in a downburst can easily reach above hurricane force under the right conditions. The last radar scan of interest was actually exactly at 1:44 p.m., the exact time the tornado was reported. Remember, the storm was not even severe warned at this time. You could see a potential weak embedded rotation there, where there's that green speck with the red seeming to wrap around the bottom. Regardless, the tornado did not last very long. As I mentioned earlier, the tornadic supercell began to merge with other cells in the area, producing a small squall line. Wind gusts in this line were frequently recorded on radar at 40 to 50 miles per hour, with some higher gusts being possible along the ground. This line of storms would weaken by 3 p.m. as they approached the east coastline. There were some other decent-looking storms in the area, but none flared up quite like that cell that went over Jacksonville. The tornado was rated an EF0 as it had caused minimal damage. A News4Jax article states that a railroad crossing in the area was damaged, but it's not known if this was due to the tornado or other thunderstorm winds. I will admit this wasn't exactly the most impressive tornado ever, but I do think the sentiment of a tornado just popping up out of nowhere onto a major city without any warning at all is pretty terrifying, regardless of intensity. I also wonder how the influence of the sea breezes and the other outflow boundaries from other storms played into this one. The sea breeze was approaching and beginning to go into the supercell at the time it would have been producing the tornado. Maybe it helped provide just enough lift? I think it's also important to analyze even small events like these, because you never know. Maybe one day a similar setup will spawn a much bigger storm. And that's all I got for today, y'all. I hope you enjoyed. If you did, you know what to do. Like, share, subscribe, all that nonsense. So, I hope you have a great day. Stay safe out there, and I will see you in the next one.